All satellites are assigned one or more sets of frequencies for interacting with a network of Earth stations. A frequency can be defined as the number of times that an alternating current passes through one complete cycle in 1 second of time. 1 cycle per second is also called 1 Hertz, named after the 19th century radio pioneer Heinrich Hertz. 1,000 cycles per second is abbreviated 1 kilohertz, 1 million a megahertz, and 1 billion a gigahertz. Each frequency has a specific wavelength, which is the actual distance that the radio wave travels during one complete cycle. With the higher the frequency, the shorter the wavelength. The most efficient way to capture any radio signal is to use an antenna with physical dimensions that are a multiple or submultiple of the desired signal's wavelength.
Now, wavelength is the distance that an electromagnetic wave travels during one cycle. It can be defined as a wavelength equals the speed of light, a constant, divided by the frequency. So we can determine the length of a single wave if we know its frequency.
The electromagnetic spectrum is the entire continuum of frequencies used to propagate signals through space. Within this spectrum, each subset or frequency band has its own unique properties. For example, the very low frequency and low frequency bands between 3 and 300 kilohertz are primarily used for communicating with submarines and ships at sea. That's because the long wavelengths of these signals propagate very well over and even under the water surface. Local AM radio stations use the medium wave frequencies from 500 to 1600 kilohertz because the wavelengths generated within this band propagate very well along the Earth's surface over considerable distances. By contrast, international radio stations use the shortwave bands between 3 and 30 megahertz. Uplinks come in two basic configurations. One is a permanent facility that is mounted onto the ground and serves as a gateway station for regularly communicating with one or more satellites in geostationary orbit. Fixed uplinks are often used to distribute live or tape events to millions of satellite receive sites via domestic or international spacecraft. These facilities at Intelsat, for example, contain the technical expertise and resources needed to support full bandwidth audio and video for viewing virtually any place in the world. The other type of satellite uplink now in use worldwide is the mobile teleport, which can transmit from almost any conceivable location reached by road. Live sporting events, for example, can be broadcast live right from the site of the event itself.
Finally, breaking his silence.
Today's mobile teleports operate almost exclusively in the Ku band frequency range. Since these transportable terminals do not share their frequencies with terrestrial microwave systems, they can arrive on the scene without having to worry about causing interference to other communication networks down on the ground. News organizations can therefore move a satellite news gathering vehicle, or SNG, quickly from site to site to uplink news stories as they happen. Some Ku-band uplinks can even function as miniature TV studios. This particular Unisat vehicle, which contains rack-mounted recording, playback, and monitoring facilities, can put a signal onto any given satellite within 15 minutes of arriving on the scene. Motorized jacks to the front and rear of the chassis are used to stabilize the body of the vehicle to ensure antenna pointing accuracy over time. This motorized antenna can travel more than 180 degrees in azimuth and 90 degrees in elevation. Moreover, the satellite downlink section of the van provides technicians in the field with the ability to monitor the quality of their own transmissions, as well as receive signals originating from other locations. The motorized antenna is adjusted to the proper coordinates, while the technician looks for an indication that the antenna is bore-sighted onto the correct satellite. Qualitative measurements are then made through the use of a rack-mounted spectrum analyzer.
Well, we would like to think we're getting there. We're not there yet, but we do supply a significant number of the Fortune 1000s with VSAT technologies. Well, 20 years ago, the value driver was, as you mentioned, lower cost and reaching a lot of sites. Today, we're in this new world of expanding broadband applications, and both internet and intranet, because corporations, of course, have requirements beyond just internet access. We now have all the new potential for broadband, which with today's satellites means media-rich or video content delivery to a lot of sites throughout North America on a similar single cost and single quality of service basis. And what's important is the companies that in this realm of emerging broadband don't really care about the technology. They want a certain grade of service, they want it to be fully managed, and so we're seeing opportunities, and our business is evolving as well to follow this trend, where as a managed service provider, VSATs are very much an integral part of a combination of technologies, whether DSL, cable modem, fiber. It's not the case anymore that one technology does it all the best. VSATs are an important part, but it's very much now an integral part of an IT strategy that covers multiple technologies. VSATs have come down in size and cost dramatically by 10 to 20 times, depending on what year you measure. And we're now in a mode where, in fact, the fastest growing part of our Hughes business is consumer satellite broadband. So the cost is now below $500 for the equipment. And that's a complete modem, router, and the satellite dish, which is typically less than 1 meter in size. And the capability is every bit as good as most DSL or a typical cable modem type services. Very affordable. Our plans start at $59.95 a month, and we're signing up over 10,000 a month. Many of these are small businesses as well as consumers. So we've gone from large enterprise to medium enterprise, from thousands of sites to hundreds of sites to tens of sites to one site. So it scales very nicely because of the low cost of the terminal now. Today, a geostationary satellite, as you know, is essentially a mirror in the sky. It has transponders, and communications come up to the satellite from a terminal down to a network operations center where the routing and control logic takes place, and all the customer care and back-end billing systems logic. And then it goes back up to the satellite and then off to one or more terminal sites.
As the opening years of the 21st century have repeatedly demonstrated, all ground-based communication systems can be devastated by both natural disasters and terrorist attacks.
Satellite is the only true alternative path to any terrestrial technology. So whether the network is fiber, DSL, cable modem, landline, twisted pair, doesn't matter. It's subject to the same conditions of a disaster should it strike, whether physical or natural.
9/11 was a horrific wake-up call that revealed just how ill-prepared many government agencies were when it came to dealing with the communications problems that can take place in the wake of a massive disaster.
One of the biggest problems that they had is when the towers collapsed, they brought all the communications infrastructure for that area of Manhattan with them down into the hole.
The third stage of deployment is to roll in a portable VSAT like this one, which Hefner says represents the real backbone of the response team's communication system. This mobile trailer unit has its own built-in generator, satellite modems, and even an auto-acquisition antenna. However, each time Orbital DataNet sells an auto-acquisition antenna, the company insists that the customer also learn how to manually adjust it, even though it will work automatically 99.5% of the time.
It's that other half of 1% that gets those phone calls at 3 in the morning when you hear nothing but police sirens on the other end of the phone and the guy going, "We can't get a satellite locate." Almost every time it's going to work until that one time it has to work, and that's when karma is going to come get you. But we also provide what we consider very high-level training, because our attitude is they've got to know how to use this gear, they've got to know how to repair this gear.
The third level is a full VSAT. Now the VSAT itself is quite compact, but it still requires either a truck-mounted unit, something that comes in and can be set up in a matter of less than an hour or so. Or another level of that would then be a fixed VSAT with a mobile power unit, maybe a generator, which we saw, for example, after Katrina in New Orleans.
This transportable VSAT terminal calculates its precise location using global positioning satellite technology, and then runs the data through an automated procedure that sets the antenna's azimuth and elevation angles to the coordinates required at the site. The antenna sweeps back and forth in small increments until it locks onto the desired satellite, after which the system automatically performs all the fine-tune adjustments required to maximize the signal reception.